less than 15. Cruz?
I was gonna say
More than 15.
24.
24.
I got 5.
9. All right. I want you to write something on the side here, something called the fundamental counting principle. Fundamental counting principle means we can get our total number of outcomes by multiplying how many of each choice you have. Okay, for example, if you have 2 shirts and 3 pairs of pants, there are 6 different outfits you can wear. 2 times 3. Okay, to prove that, let's say you have a blue shirt and a red shirt, and you have jeans, you have khakis, and you have shorts. Well, you can wear your blue shirt with your jeans, that's 1. Blue shirt with khaki, blue shirt with shorts, that's 3 options, right? You could also wear red with jeans, red with khaki, red with shorts, that's another 3 for a total of 6 outcomes.
Oh, I know.
Okay, 2 times 3.
Okay.
2 shirts, 3 pants. So, same thing with courses and side dishes. How many main courses we got?
3.
Side dishes? Drinks. Multiply them to tell us how many possible outcomes we have.
18.
18 is the correct answer. Now, if it would say sample space, I would have to list them all out. Grilled chicken, salad milk, grilled chicken, salad juice, grilled chicken, salad water, grilled chicken, applesauce milk, and so on. Okay, there are 18 of them, but it does not say sample space. It was just asking us for outcome. Question 2 leads us, how can we do that as a little bit of organization? There are 3 different ways. You can make a list, you can make a table, you can make something called a tree diagram. And we're going to do one of each here and see if you have a preference. You can use that method. So if you're flipping a coin, how many options do you have? 2, heads or tails, right? Rolling a die, 6 outcomes. I can get 1, 2, 3, 4, 5, or 6. So how many total outcomes should I have? No. 12. 2 times 6. Just like we multiplied here, you multiply 2 times 6. So whatever you do, you should know you have 12 outcomes. Okay, so Kieran, Elena, and Priya are using a different method. Elena just writes them all out. Okay, makes a list. Heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. So I can get a heads and then roll any number. Then does the same thing for tails. How many outcomes does she have there? 12, which is what we said she should have, right? Next page. Kieran likes to make a table. You list one option going this way, so that's my coin, obviously, heads or tails. Here's my dice going the other way, 1 through 6, and you complete the table. Heads 1, heads 2, heads 3, heads 4, and so on. How many different outcomes do we have? 12. That's how you can make a table. Priya makes something called a tree diagram. Again, first outcome here, heads or tails. And then I can get a 1 through 6. So I would also finish this and write heads 1, heads 2, heads 3, so on. Or I could roll a tails and a 1. Tails 1, tails 2, tails 3, so on. How many different outcomes do we have there? 12. So the way you do it, it does not matter. You get the same answer. Okay, question 1. Leroy, would you read it, please?
Compare these 3 methods. What is the same about each method? What is different? Be prepared to explain why each method produces all the different outcomes without repeating any.
Okay, what's the same about each method? Same answers. We're going to have 12 outcomes and a list of the entire sample space. Anything else that's the same about those 3? Okay, what's different? Matthew,
How to get the outcomes?
different way of organizing? Sure. Different structure? However you want to say that. And question number 2, I want you to answer on your own, and then we'll discuss. Personal opinion question. List, table, or tree? All right, out of curiosity, who prefers the list? Just writing them out. Couple? How about a table? A few more? How about the tree? Following the branches, okay, so that seems to be the most popular. If it doesn't ask you to do it one way, you can do whichever way you choose. We'll probably kind of choose one of each here so everybody gets a chance to do their favorite. Question number 3, Molly, would you read the top part, please?
Find the sample space for each of these experiments using any method. Make sure you list every possible outcome without repeating any.
All right, so we need to list every possible outcome. We're looking for the sample space then. Every outcome needs to be listed. So the first one, flip a dime, flip a nickel, flip a penny. Record whether they land heads up or tails up. So first thing I want to do is decide how many outcomes I should have. Flipping a coin 3 times. How many different things can happen?
6.
No. Did somebody say something? No?
9.
What?
9.
Nope. What? Who said that? What'd you say?
3.
No.
4.
You're guessing.
5,
You're guessing.
7,
You're guessing.
3.
Okay. How many outcomes do we have on flipping a dime?
2,
How many outcomes do we have flipping a nickel? How many outcomes do we have flipping a penny?
2.
That is not 6.
8,
That is 8. You literally multiply them together, guys. Not 2 times 3. 2 times 2 times 2. So I need to have 8. All right, we're going to do a tree diagram here. Normally I wouldn't care, but we'll show you one of each. So we're going to do a tree. So flipping a dime, it doesn't matter if it's a dime, quarter, whatever. It can come up 2 ways. Heads or tails. So that's coin number 1. Now when you switch outcomes, you're going to branch off of that. And what are the outcomes up here? Heads or tails. And then that repeats down here. So if I follow branches after 2 coins, I could get heads, 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 tails, tails, heads, tails, tails would be the 4 outcomes. But I have 3 coins. So what do you think I got to do yet? Do another branch. And each one will have the same thing off of it. So that's coin 1, coin 2, coin 3. Now we're going to follow the branches. Parker, follow the top branch for me.
heads to tails.
Top, top, top.
Oh, just heads, heads, heads.
Okay, so you could get all heads. Now we go heads, heads, tails. Okay, now we did that line. Now we go to the next line. Heads, and then heads. So that's half.
And then we go tails.
Now you start on the bottom.
Tails, heads, heads.
Tails, heads, tails, heads, tails. So now we just got the bottom way to go. All right, so those are the 8 options.
That is the sample space. I'd take note of that. Anytime it's talking about 3 coins, it's not going to change. Bless you. Just out of curiosity, if I would do 4 coins, how many outcomes?
16.
16. If I would do 5 coins, how many outcomes?
20. No. 32.
32. 2 times 2 times 2 times 2 times 2.
And then 64.
That's 64. If you get up that high, I'm not going to have you list them all, but I might ask you how many outcomes there are. All right, question B. This is kind of like the one I just introduced up here. Hans' closet has 3 shirts, 3 pants. Select 1 shirt and 1 pair of pants to wear for the day. So again, how many outcomes do I have? Well, how many shirts you got?
3.
How many pants you got?
3.
So as long as you can multiply, we should be able to answer the first part.
9.
9 outcomes. Want to do a list or a table with this one?
Table.
Table. All right, so this one we'll do a table. So on one side will be shirts. And on one side will be pants. I know there's going to be 9 outcomes, so I better have 9 spots in my table. So shirts, I got blue, gray, and white. Pants, blue, khaki, black. And I'm just going to make a little note here. The first letter is going to be shirts. Second letter will be pants. And then I won't have to write them all out. I can just abbreviate. All right, so what's this one going to be?
Blue, blue.
Blue, blue. This one?
Blue, gray.
Nope. I said shirts was first.
Oh,
Gray, blue. And
white, blue.
white, blue. So blue shirt, blue pants, gray shirt, blue pants, and white shirt, blue pants. Next one. Shirts first.
Blue, khaki.
Blue and khaki. Next one.
Gray and khaki.
Gray and khaki. Next one.
White and khaki.
White and khaki. Last row.
Blue and black.
Blue and black.
Gray and black.
Gray and black.
White and black.
White and black. Again, you better have 9 options. That's how you can use a table. Okay, so we haven't done a list yet, so we'll just do a list for C. All the possible outcomes. Let's go with Dakota. How many options we got? How many total outcomes should I get? Yes, 4 and 5. That'd be 20. 4 times 5. 4 things on this spinner, 5 on here. Total of 20. 20 outcomes. All right, so which color you want to start with? Red. So I could get a red and then a...
1,
I could get a red, then a...
2,
I could get a red, then a...
3,
I could get a red, then a...
4,
And...
5.
Or I could spin a blue first. I could get a blue and a... Blue and a 2, blue and a 3, blue and a 4, blue and a 5. I could get green and 1, green and 2, green and 3, green 4, green 5. Same thing with white. And there's all 20. Okay, I want you to do D. Any way you want. Tree, table, list. Write them out. Bottom 65. Whatever method you want. Write them out.
to draw a clock.
Well,
Make a list, table,
would that work though?
tree diagram, or draw a clock. I don't remember that even being an option. How many outcomes are you gonna have?
24.
Why 24?
AM and PM is 2.
AM and PM is 2.
And then there's 12 hours.
12 hours on a clock. 12 times 2.
Anybody make a list? Anybody make a table?
I'm making a table for
Anybody make a tree diagram? Anybody draw a clock? All right, there they are. All 24.
That's a lot of numbers.
Again, if you know, actually there's more letters there than numbers.
Oh.
If you know how to figure out how many you have, that's a really helpful hint to how many answers you should get. Okay, just multiply them. Next question. This is really interesting if you think of like a Subway, how many different options you have. Okay, number 1, Dieterle, would you read it please?
A submarine sandwich shop makes sandwiches with one kind of bread, one protein, one choice of cheese, and 2 vegetables. How many different sandwiches are possible? Explain your reasoning. You don't need to write out the sample space.
Thankfully. Don't need to write out the sample space. If it ever says that, take advantage, because you're going to see how many we'd have here. All right, so how many outcomes do we have? Now, based on what Dieterle read, remember how many of each you want. I kind of underlined it as he read it. What do you think?
240?
No. You're missing one part. All right, so one type of bread. How many breads we got? 3. One protein. How many proteins we got? 1 cheese. How many cheeses we got? Cheese options, I should say. 4 options. 2 veggies. So, how many veggies we got? Nope.
4.
Well, look how many veggies we got. There's 5. Now you get a second choice of veggies. How many choices you got? 5. Because I could get double lettuce, for instance. That's why your 240 was wrong.
I'm close.
2 veggies. 3 times 4 times 4 times 5 times 5.
1,200.
1,200 outcomes. That's why it says you don't have to list the sample space.
That would be a lot.
That'd be a lot. Trey, you can if you want.
You probably will.
Number 2, Jackson, would you read, please?
Which one?
2. 2.
Yeah, but which one?
You. Because you're the one talking.
Andre knows he wants a sandwich that has ham, lettuce, and tomatoes on it. He doesn't care about the type of bread or cheese. How many of different sandwiches would make Andre happy?
Okay, he wants ham, lettuce, and tomatoes. So he doesn't care about the bread or cheese. So that means this is what he's choosing, or has options of. You know he's getting hams, and you know what he wants for veggies. So, how many options do they have to make bread for him? Because he doesn't care which kind he gets. They could grab 3 different kinds. Cheese options, 4. So how many sandwiches would make him happy? 12. 12 sandwiches would make him happy. Question 3, if a sandwich is made randomly, what's the probability that he'll be happy with?
1 out of 12. No.
How many sandwiches would he be happy with?
1 out of 1,000.
How many sandwiches would he be happy with?
12.
12. How many total options were there that we said?
1,200.
So 1 out of 1,000. No.
1 out of 100.
Oh.
So he's got a 1% chance of being happy with his sandwich.
1% chance
Question. Are you ready? I guess there's no number there. Describe a situation that involves 3 parts. That would have a total of 24 answers. So I know they're gonna have to multiply to give me 24. So somebody start with something I can do.
2.
Okay, what can I do that would be 2? 2 options.
I don't know.
Can't think of anything that would be
10.
pencils.
Oh,
I think I know.
I thought you
Um,
meant.
Heads, how about flipping a coin? Yes.
Okay.
Oh,
I was thinking.
10.
I was thinking.
Flipping a coin has 2 options, or pencils. All right, so I have a 2. I need another number.
10.
2 times 10, and then what would I take it times to give me 24?
6 pencils.
Multiply.
12.
Oh, that's 10.
6 times.
6? What can I do that has 6 options?
Nine.
Rolling a die.
And then.
Okay, so I have 2 times 6, which is 12, so I need another 2.
Yeah.
Can't use the dice again, I want something different.
Mustard or ketchup.
Picking mustard or ketchup.
Or drawing marbles.
Yeah.
Or drawing marbles. So, flipping a coin or pencils for the first one, rolling a die, and picking ketchup or mustard. 2 times 6 times 2. Okay, you wouldn't have had to use those numbers, but they do have to multiply to give you 24. Okay, next page, 67. Again, if it doesn't tell you which way to do it, you can do any way you want. Tree diagram, table, list, completely up to you. Okay, next page. First question there is talking about a birthday party. You have a theme, location, and a day. Okay, all these questions are pertaining to this. Answer accordingly. Okay, remember, think about how many options you should have. For each event, write the sample space and tell how many outcomes there are. I would do the outcomes first, and then you have to write out the sample space, so you cannot just write a number, you gotta write them out. Okay, I do not care if you do a table, a list, or a tree diagram. Does not matter to me, it doesn't say. Your choice, A through C. Next question. This is, again, just like the battery question that you had, just like the cat one yesterday, talking about making a kick or not, making a field goal or not. A 1 means they made the kick. Based on these results, estimate the probability that 3 or more kicks are made. That's what you're looking for. 3 or more kicks are made based on these 5 trials. That tells me the denominator, remember, is 5. There's 5 trials. And question number 4, talking about the marbles. Andre does a trial, Jada does a trial, Noah does a trial. Estimate the probability of green marble. See what you think on that one. Based on those results of those 3 people, what's the probability of drawing a green marble? All right, that is it for today. So for only 4 questions. And you got about 7 minutes to work. Should give you a good jump start today.